Yeah, you remember when you joined our group? Yeah, we talked about this snipe count experiment. It was like a year and a half ago,
Exactly.
and you were actually a bit scared of it. You thought that it's going to distract you from your real work, right?
Yeah.
And it did.
It did.
And the question is, what are we doing in the woods there with our equipment? Strange people, going around carrying these tubes and cables and so on. And the answer is more bizarre than the question, actually. It is that we are looking for dark matter. Physics is at the basis of all the technologies, and we see these wonderful technologies around us. And yet, we are in a very embarrassing time for physics because we have a number of basic questions that physics has not been able to find answers to. And one of them, surprisingly, is the question of what is the universe made of. But it turns out that everything that we can see is only a small fraction of the stuff that exists in the universe. And the rest of it seems to exert gravitational forces. While we don't know what it is, people have very many ideas, and the range of possibilities is just mind-blowing. For instance, you can say perhaps it's some kind of a new particle that is not part of what we now call the standard model of particle physics, that has certain particles and fields in it, and that is something else that it's not in the standard model. And the mass of these particles can in principle be anything from very, very light to very, very heavy. Depending on how these particles interact, we set up, and what is the mass of these particles, we set up different detectors for them. And in particular, we're interested to this class of dark matter models that is called ultralight bosonic dark matter. While we know that electromagnetic field is made out of photons, the particles of light, but if there are many of them and they sort of in the same quantum states, then we can also describe them as a field, and we are looking for this kind of dark matter.
Yeah, so one can try to look for dark matter in many different ways, and if we think that the dark matter is a super light particle, like orders of magnitude lighter than an electron, one could imagine that this particle could be what people call an axion, and it will still interact with normal matter, but in a very tiny way, so we haven't detected it yet. And the idea of this experiment is trying to look the interaction of this type of dark matter with the Earth magnetic field. And then if you try to do that in a lab or in the middle of a city, you have the problem that you have a lot of magnetic noise just for our phone, from anything that is inside a city. That's why we are going hunting for it. We go to a forest and we try to find dark matter in an environment where we can actually see changes in the Earth magnetic field, and if we see a particular signal in certain frequencies that we don't expect the Earth magnetic field to just naturally do, then that could be a very good indication that there is this type of signal and there is dark matter out there. I mean, doing things when you are not in a lab is hard because everything can go wrong very easy, and it was actually very stressful to try to have everything into account. The setup consists on 3 induction coil magnetometers that have a sensitivity up to femtotesla. And we set it up in the forest with some data acquisition system, and then we correlate these measurements with the one that other teams are taking in the US. Sure, and we have a tent that protects it from the rain, that actually ends up being really an important factor because it really rains.
Took about a year and a half to collect all the equipment, tune it, decide what we want to do, etc. And now, at the same time with the American teams, we're here in Bavaria.
This all started, I guess, on one day that Ophir and I were chatting on Skype, and he was saying we got these constraints, like we had to make a triangle with certain, elevations and so on. And so I started looking around the places I know, and well, we found this forest and I think it's been successful, let's say. We'll know once we look at the data. What we were mostly looking for was, or at least me, is that sometimes in the maps you can't really see so certain power lines, or if there's some of these windmills. So I think it's also important to come and scout the area to see if there's a lot of activity, if people are walking around, if there's a lot of cars moving around. And it turned out, I think, that we were all impressed at how quiet this is and that there's nobody. And yeah.
But the origin of this project actually is very interesting. It has to do with one of my former PhD students and now a famous professor, Derek Jackson Kimball. And he's a very passionate physicist and teacher. But when he grew up, he was also a very passionate Boy Scout, and he retained his love for hiking and nature. And so this particular experiment, which was proposed by Derek and friends, combines sort of Derek's passions. It combines nature, hiking, and being with his students, and as well as doing some fantastic science.
Well, I was actually brought on the team about 2 weeks ago for some technical help about a problem with the electronics box. And in this procedure, I found out that something can only be learned through trial and error. For example, in the setup, there was a part called a GPS head that connects to a satellite signal. It never works in our test in the office until we found out that we have to open the window and put the whole electronic box outside the window. And it worked. It must look pretty funny from outside the building. And my favorite part about this project is when I was assembling that whole electronic box, and I have to use a drill bit much bigger than the expected diameter to drill a hole. And we only have one chance, and luckily I made it. Now we are in the forest to do our experiment. I even see a snake for my first time in my life, and I feel very happy to be here. Thank you.
This project is called SNIPE Hunt, which stands for Search for Non-Interacting Particles Experimental Hunt. And I came from Arizona to Mainz, Germany to work on the project. And this project is a global collaboration, so we have many different collaborators from all over the globe performing the same experiment under the same parameters at the same time. So you would imagine how ironic it was when I found out that one of our global collaborators is from California. So they're performing the same experiment one state over from my hometown. But when I was looking up Snipe Hunt to read some literature on the project, I realized that Snipe Hunt is a total play on words, and it actually means a search for a mythical creature, just like we are searching for the axion, which is a theory yet to be proved. So it's exciting to be a part of a snipe hunt. In the forest was really fun, and setting up the tents. You know, I'm from the desert, so everything was very green, and spending time in forest was special.
The future of snipe hunt. What we want to do next? That's a good question. So we couldn't attempt the 3 magnetometer measurement when we require different elevations, and that will be cool to do probably next year. We need to check if this is a good location, if the magnetic noise is fine, and then depending on that, maybe we repeat here, we go to a different place, and we definitely need to check the data and see what we have. We are really excited to go back and see if we actually have real data and good quality data.
This is not the only experiment that we brought with us from Mainz. So the other experiment is spearheaded by a PhD student in our group. Her name is Anne.
Okay, so my project is focused on measuring magnetic fields that are produced by living plants or fungus. And I use atomic magnetometers to do this. So basically the electron spins of the atoms are sensitive to changes in the magnetic field environment, and then we can read out these changes using laser light. And we've used this approach so far to measure magnetic fields from carnivorous plants, specifically the Venus flytrap. And now we're expanding to other systems. And for this reason, we decided to go into the forest and see if we could measure magnetic signals from the forest floor, which might be caused by electrical activity in the root network. So tree roots form symbiotic relationships with fungus, and in this way they can share information and nutrients and so forth. This is not so well understood, but we hope that by using non-invasive techniques like magnetometry, we can be sensitive to tiny electrical signaling that may be going on in the forest floor. Basically, the root structure can be as big as the branch structure, although the way that trees grow depends on whether they grow alone, so like a single tree in a field, or more of a network of trees in a forest. It is meaningful to me personally because the forest for me has always been kind of a healing place to go whenever I feel stressed or overwhelmed, and this was the first time that I actually conducted research in the forest, so that was kind of fun to bridge the gap between lab work and actual measurements in the field in an environment that's special to me.
I think it's quite cool, the magnetic field. It's everywhere. It has long range. You can measure magnetic field and electromagnetic field, like photons from distant stars. But you can also measure that on atomic level. How we combine these two, right? We measure something on a galactic scale even more. And at the same time, we put a magnetometer close to a tree trunk. So I think that's why I'm passionate about this. The most meaningful, of course, is team collaboration. I think it's a really nice experience to have the real professor sitting here. Well, let's say we have a lot. And I like these camps out with the tools, with sensors. I don't know. Probably we'll also have this, what's called marshmallows, s'mores. Yeah, so I'm looking forward to that. It should be a good reward. Well, it's not a common thing to have s'mores in Ukraine, where I'm from, but I knew about them, like hypothetical particles, and I hope we can measure some today too. Measure the sweetness of them. It was a lot of fun to find the spot where we measure. We kind of found really nice, pretty camping spots. Also, it was fun to get an Ausweis to get the measurement.
Just like Derek envisioned, he gave us instructions. The most important thing is to have fun. Singing songs with the guitar, not around the campfire, but in this Airbnb.
Like our magnetometer.
Even though it all went wrong, I'm standing here before the Lord of Song. I shall
Alright, good. Thank you so much.
So good.
If you come here to this beautiful location Airbnb, you would think that it's populated by crazy people, because most of the time we are actually working, reading papers, typing away at our computers, setting up Arduino data acquisition systems, etc. But we do also find time for fun. We have 3 Americans, a Ukrainian, and a Chinese person, and a Spanish person, so very international.